Good morning, everyone. Good morning. Hope all is well. Hope everyone is doing all right. Sorry about that. Sorry about rolling a little late. Sorry about the extra conversation I had to have real quick. But there's those things you got to deal with when you're at home, right? So yeah, apologize. So we were in chapter 4 last class, and let's go ahead and get back into it. Okay, we did all that. 342 should be at 4-3. All right. So should be able to do 4-3 and 4-4 today. 4-3 is modeling linear trends. So we're going to look at the regression line. So the regression line is going to be a tool for making predictions about future observed values. So it also provides a useful way of summarizing a linear relationship. Right. So that takes us into the equation of a line, which is y equal to mx plus b. Some of you guys may remember from algebra, the slope-intercept form, y equal to mx plus b, where m is your slope, or in other words, called the average rate of change, and b is your y-intercept. That more so pertains, when you call it the y-intercept, more so pertains to graphing. You know, that's where the graph intercepts the y-axis. I don't want to scroll up too fast. All right. That's just re-emphasizing the position. The slope is always the letter that's attached to x, the one that's sitting in front of x, and your y-intercept is always the other number. All right, right down with the purple. Okay, let's start right there. So the regression line in context. So we have a college instructor with far too many books on his shelf, and he's wondering whether he has room for one more. He has a 20 millimeters of space left on his shelf. He can tell from the online bookstore that the book he wants has 598 pages. The regression line is, so we'll talk about how to find and calculate the regression line soon. But in this case, they give us the actual regression line. So notice they have predicted width is equal to 6.22 plus 3.66 pages. So when you talk about X and Y, your Y would be the predicted width, and then your variable for X would be your pages. All right, but the way your book sometimes shape it, they'll give you the actual word instead of the variable itself. So they would have given you predicted width equal to 6.22 plus 0.366 pages. All right, can I scroll up? So the rest of it says, will the book fit on the shelf? So we have this regression line, and that regression line has been created by past observations. And like I said, we'll see an example of how we can create the regression line in a second. But you have past observations, plug them into a formula. It gives us this regression line that would allow us to predict, future observations. So we'll be able to predict based on his past books and past measurements. If you have a book that's 598 pages, how thick the book will be according to this regression line. So some of that I said right here in the dark purple, regression line is based on previous observations. Because of those previous observations, you are able to make a prediction on future observations. Wasn't even looking at that, I was just talking. So yep, right there. Scrolling up. So we're going to take that 598, plug it into the equation for pages. So that's 6.22 plus 0.366 times 598. And that ultimately, following order of operations, do the multiplication first, then addition. That gives us 28.1068 millimeters. And of course, pay attention to MATLAB and how many decimal values they want. If they want the answer, they only want to the 10th place, 100th, or so on. So make sure you're careful with that. Let's scroll up. All right, so based on the regression line, the book should not be able to fit on the shelf. If you go back to how much room he only has 20 millimeters, and this is 28 millimeters, excuse me. Any questions? Any questions? Scrolling up. All the way up. Everybody good? All right, so finding the regression line. Your slope is going to be B equal to R times S sub Y over S sub X. I'm gonna scroll down in a second so you'll see what those variables mean. The intercept is A equal to Y bar minus B times X bar. The regression line will be Y hat equal to A plus BX. So last class we saw what R was. R is your correlation coefficient. X bar is just the mean of your explanatory variable. We're going to talk about the difference between explanatory and response variable in a few before we close out today. But the way they introduced it, they didn't really introduce it the proper way. But anyway, this is how the book was going. Anyway, so your explanatory variable is going to be X. And then the standard deviation of your explanatory variable is S sub X. That's what we're talking about here. Then your response variable, which is Y. We got the average of that, your mean of your response variables, and the standard deviation of your response variables. And Y hat is just your predicted Y. Remember what we just did with predicting the thickness of the book. So that means that the pages would have been X. The thickness of the book would have been Y. And so that prediction would have been called Y hat. All right, let's scroll up. All right, so let's look to use these formulas. So if I don't the black. Okay, so I wrote this as short as possible with still giving you as much context as possible. That's why you see these little dots right here. I had some more information within this, so I shortened it up as much as I could. So a college in the US used SAT scores to help decide which applicants to admit. To determine whether the SAT was useful in predicting success, the college examined the relationship between SAT scores and first-year GPAs of admitted students. The average math SAT score of the sample was 649.5. Whoa. With standard deviation 66.3. So I'll pause right there, let you guys get caught up. All right, so let's see here. Erase some of this stuff. So then we have the average GPA was 2.63 with standard deviation of 0.58. Then the correlation between them was 0.19. All right, let's scrolling up some. So first question from the problem, find the equation of the regression line. Note that they tell you that X is equal to your SAT, Y is equal to your GPA. All right, done with the green. Can I scroll up more? All right, and then use the equation to find the predicted GPA of a person with SAT score of 650. All right, so first thing we want to do is extract all the information from the problem accordingly. So SAT, there's our mean and our standard deviation of our SAT, and then the mean and standard deviation of our GPA. And so that's what we have right here. And then the last piece was our correlation coefficient, that's R. So it's always good to list out what given pieces of information that you have that the problem gives you. All right. So from there, we can, if we go back to our formulas, we have all these pieces, and we're going to use each one of these formulas to get our regression line. So here we're trying to find B first. We have to find B first because if you notice a part of A in the formula to find A is B, so you have to find B first. So we have 0.19 times 0.58 divided by 66.3. That gives us 0.001697. Then we use this formula right here to find A. So that's Y bar minus B times X bar. That gives us 1.53. Everybody okay? So you can represent your regression line one of these two ways. You have A plus BX, just emphasizing that right there as far as the green is concerned. So A was 1.53 plus 0.0017. And once again, pay attention to how MATLAB wants you to round off. We had 0.001697 at one point, but if MATLAB only want 4 decimal places, make sure you only use 4. Or they could ask you, or they could set it up for you to write it this way: predicted GPA, because remember Y hat is going to be your predicted Y. Y was your GPA. So predicted GPA equal 1.53 plus 0.0017 times your SAT, which is, remember, was your X. So either one of those ways would be acceptable. MATLAB will set you up as to how they want you to plug it in. They probably have boxes that you'll just type in the number, and you just got to put the number in the right spot. All right, questions? Any questions?
So can you scroll back up a little bit to where you did the regulation line, like with the slope and the intercept? Right there.
All right.
I just need a little bit, that bottom part.
Yep, let me know when you're ready.
Okay, I'm done. Thank you.
No problem, no problem. All right, so is everybody done with A before we go to B? All right, so B, they gave us 650. B was saying use the equation to find a predicted value or predicted GPA of a person with SAT score of 650. So that means X is 650, and you plug 650 into the equation that we just created, and that's going to be 2.635. So that would be our expected GPA or predicted GPA. All right. So this is the title of the next piece of this section, and then I got to go to another set of notes. So you got a chance to copy down that title. Then we're going to go to another page of notes. All right, are we good to go? Everybody straight? All right, so where we at? Here we go. Let's just go right here. So your explanatory variable, I thought I wrote this. Did I want more on that? Okay, well, anyway, here it goes. We're looking at your explanatory variable versus your response variable. And the difference between the two, the order does matter. So your explanatory variable is supposed to explain what's going on. and your response variable responds to your explanatory variable or is explained by the explanatory variable. So an example that we're going to have is you have a golfer and you record how fast his golf swing is, the golf club head speed. And so if he hits the golf ball at 103 miles per hour, then the distance will be such and such. Well, then if you hit it at 100 miles per hour, your distance will be whatever, and so on. So your explanatory variable will be how hard he hits the ball, or how fast his golf club is swinging. And then the response variable will be how far the ball travels. So that's what we're talking about, having an explanatory variable versus your response variable and what that means for us. So also your explanatory variable, whatever you decide your explanatory variable will be, that's going to be the same as your X value. So that'll be your horizontal axis. Your Y variable will be your response. That'll be your vertical. Your domain and range, input versus output. Remember how we plugged in the pages and got out the thickness of the book. So, your explanatory variable was what you plug in, response variable is what you get out. Independent versus dependent, then your predictor versus your predicted. Remember, we were trying to predict how thick the book was going to be. And we already talked about scatter plots, but yeah, scatter plots are always in that first quadrant. All right, are we good to go? Questions? Everybody good? Straight. Think that's it, but hold up. Everybody straight, right. Okay, I want to make sure there was nothing else I was supposed to pull from this section of notes before we go to the next thing. We'll copy that later. All right. Yep, that's good. So let's go back. All right, so that's 4.3. Trying to make sure that I had more to do. We got the regression line. Let's do this. Yeah, let's do this problem right here, just in case you see one like this. So in the last problem we did, we had the information given to us in pieces. They gave us the correlation coefficient, they gave us the average and the standard deviation of our explanatory variable, gave us the average and standard deviation of our response variable. So, but you may be given the data in just a list. And so what you would do there, that's what I want to show you right now. So first thing here, we want to find the regression line. Then we're going to predict the distance the ball will travel when hit with the club head speed of 103 miles per hour. Determine the residual for the predicted value from the result in B. Is the distance in the table above or below the average among balls hit at 103 miles per hour? So I'll give you a chance to write that down. All right. Everybody holding on to B. All right. So here is our set of data, our set of observations. We have the club head speed. That's at miles per hour, the distance at yards. And so, you see the first observation is when he swung it at 100 miles per hour, the ball traveled 257 yards. Next one, swung it at 102 miles per hour, the ball traveled 264 yards, and so on. So all of these are your explanatory variables, and these are your response variables. All right, so can we go to another page real quick? Everybody good? All right.
1 second.
All right.
I'm done.
All right, cool. All right, thank you, thank you. So let's go to Google. We talked about this last class as far as calculating correlation coefficient. Remember I said using easycalculation.com is a great option. Same thing with the regression line. I would type in what I'm trying to find, regression line, and then at the back of that, put in easy calculator or easy calculation. So that's what I did here. The first one is what comes up. And then from there, I should have left my values in from last class. So we got 100. Just want to show you guys how the values will look once we get them. 102, 265. All right, almost there. All right, so very similar to how we did the correlation coefficient. And then you see we get our information here. So if they just give you the data set, you can just plug it into easycalculation.com or something of that nature. Say it again. Was that for me? All right. So yeah. So and also always make sure that you pay attention to MATLAB, decimal values, and all the good stuff like that. Notice they give you the slope separately, then they give you the y-intercept separately, then they put it into the equation itself. Okay. So questions before we move off of this page. Everybody good? Everybody straight? All right. Let me get off that page. So that's where we got A, from that calculation. So once again, not holding you to knowing how to use the formula, but I am holding you responsible for having something reliable that can calculate the regression equation or the regression line for you. All right. Also pay attention to your signs. If 55 is negative, make sure it stays negative no matter what order you have to put it in. Whatever is attached to X needs to stay attached to X, So always make sure you paying attention to the details. Okay, so B says predict the distance the ball will travel when hit with a clear head speed of 103 miles per hour. So all that means you're going to take the 103, plug it into your equation. Once you do that, you get your prediction. So here we're predicting that with the equation that if you hit the ball at 103 miles per hour, it will travel 270.3 yards. All right, any problems before we go to C? All right, C, determine the residual for the predicted value from the result in B is the distance in the table above or below average among balls hit at 103 miles per hour. So the way you calculate residual is right here. The residual is also called the error. So it's your observed Y minus your predicted Y. If you do not have an observed Y, then there's no way for you to calculate the residual. Our predicted Y came from right here, but then also we have an observed hit at 103 miles per hour right here. So that's where we get a 274 from the chart. The 270.3 is from the equation. Here's just the symbols for it. Your observed Y is just Y. Your predicted Y, though, is Y hat. And we get 3.7 when we subtract them. All right. Any problems? Any problems? All right. So to finish it off, just an interpretation of what that means. The observation in the chart is above average balls hit at 103 miles per hour. And because 3.7 is positive, that's why you would say it's above. If 3.7 was negative, then you would say it's below the average balls hit at 103 miles per hour. All right, questions, any questions? All right. Can we go to the next piece? Anybody still copy? All right. All right, so 4-4, it's going to be a little short for us. Just a few things to that they notate for you, pitfalls to avoid. So I just wrote a few things that you may see. They may mention it in Math Lab as a question, but nothing major here until we get to that last step, the last topic. So pitfalls to avoid. So don't fit linear models to nonlinear associations. So mentioned it before, regression line is only for, and the correlation coefficient really is only for your linear associations. This only helps you and helps you predict linear models. So remember, we had a model that was an arc and one was a wave and stuff like that. So if it gets into that funky stuff that's nonlinear, then the regression line will not work for you and it will not predict accurately for you. Correlation is not causation. We talked about that, how just because there's a strong correlation does not mean that that is the cause of what you are doing your research on. Beware of outliers. Outliers do affect your correlation coefficient. It is not resistant. Regressions of aggregate data, in other words, groups of data. It's good to be used. In other words, it's good to use for groups of data. And then don't extrapolate. Don't make predictions beyond the range of your data. And so what do you mean by that is that, you're going to have a certain amount of data. You cannot predict past that. So an example that they gave, like if you have a group of people, of young people, let's say up to 12 years old, and you are trying to predict height. Well, after that, majority of kids start to go into puberty and everything. So you cannot necessarily use that information to predict the height of 16-year-olds, 17-year-olds, because there's a wave, or not to say wave, that the gradual growth changes for people in puberty. So basically you just can't make predictions beyond the information that you have. All right, scrolling up some. All right, you can copy down that title, and then we'll go to the last thing. So on another page, coefficient of determination. All right, anybody still copying? All right, everybody good? Okay. So coefficient of determination, last thing out of chapter 4, it measures the proportion of total variation in the response variable that is explained by the regression line. It basically tells how reliable the regression line is. It is the correlation coefficient squared. It's denoted by R squared, capital R squared. So that's the symbol you use for it. It's also between 0 and 1 inclusive. All right, scrolling up. So if your coefficient of determination is equal to 0, the regression line has no explanatory variable
Can
value.
you go back down, Mr. T, to the second point? Yep, right there.
All right, no problem. And then if it's equal to 1, the regression line explains 100% of the variation. So I'll pause right there and let you guys get caught up. All right, we okay? Scrolling up. Oh, that's the last one before the example. All right. So determine and interpret the coefficient of determination for the club head speed versus the distance. Anybody still holding on to the black? Everybody good? All right, so once again, we're going to determine and interpret the coefficient of determination for the club head speed versus the distance. That's the chart, not the chart, for the data value that we just finished looking at, the data set that we just finished looking at. So the correlation coefficient, I think we found that last class. I believe so, but that's where we've got a number. And remember, that's when you go to easycalculation.com and correlation coefficient, type in those data values, and you'll get 0.939. So that's why there's no work for that. That's just going to, like I said, the website, typing in data values and getting that result. So that's the first step. Second step is you want to square it. So your coefficient of determination is your correlation coefficient squared. So we take the 0.939 squared is 0.882 or 88.2%. All right. So now the interpretation. 88.2% of the variation in distance is explained by the regression line. Subtract that from 100, that gives you 11.8% of the variation is explained by other factors. So other factors could be a wind. I don't know, maybe your golf ball hits a bird, I don't know, something along those lines. Maybe you twisted your hip one way that you normally didn't with all those other observations. So that's where the 11.8% will come into play to explain why the regression line did not, come up accurate, along those lines. And then regression line has 88.2% reliability. All right, questions? Any questions? All right, so that's it for chapter 4. That's it for chapter 4. So next class, let's see. Next class will be a review day. It'll be option for you guys or opportunity for you guys to ask whatever questions you want to ask. So you have up to this point. Don't worry about this assignment one, it's not you guys. But we've talked about, or covered chapters 1 through 4. I believe everybody's giving definitions. If not, then make sure you give those to me. And then now you have test 1 and 2 available for you to knock out. I believe I posted test 2 already. I'll go in and check. But this is what you guys are responsible for up to this point. So next class, I don't plan on doing anything new. It'll be on you guys. And the way I do review days is for you guys to go in and bring your questions to class. So if nothing else, go into Math Lab, see if you have any questions, especially, taking a look at the test review, see if anything, generates questions or pique your curiosity in such a way that you can't figure it out, whatever the case may be. Bring it to class and we'll talk about it, whether it be from chapters 1, 2, 3, or 4. And we'll go from there. If you guys don't have any questions, It'll be a short class. All right. Questions on anything I've said? Everybody good? Everybody straight? So also take note, remember I told you, this stuff can happen quick. You know, we're done with 4 chapters. You know, that's why I say that you most definitely want to make sure you stay on top of doing this math lab work, because next thing you know, you look up and we in chapter 7, you know, if you're not careful. So make sure you guys are staying on top of your work. And if you guys are good, I'm good. Have a great weekend. Be safe. And I will see you on Monday.
Thank you.
Thank you.
Thank you. Thank you. Take care.
Thank you.
All right. Take care.